Welcome to The Explainer. We're taking on a massive, super fascinating project today. We are going to take Kevin Kulp's incredibly deep technical walkthroughs of Supermicro's SuperCloud Developer Console and distill them down into a literal step-by-step blueprint. By the end of this, you're going to see exactly how a modern multi-tenant AI data center, what we're calling the NeoCloud, is actually built from the ground up.
Okay, let's dive right into this construction blueprint. First, we'll cover the AI factory paradigm, then storage and network foundations. After that, building the control plane, instantiating virtual machines, deploying AI containers, and finally, we'll wrap up with the NeoCloud future.
Starting off with Section 1, the AI factory paradigm, and exactly why legacy IT fails.
So, you gotta ask yourself, can a traditional one-size-fits-all IT platform actually handle the AI data centers of the future? The short answer? Absolutely not. Right now, data center operators are facing a serious dilemma. The race is officially on to build hyperscale-class AI data centers. Honestly, it looks a whole lot like that frantic rush of Bitcoin operators back in the day. You need massive scale, sure, but you also need absolute precision to manage it all.
And this brilliantly illustrates the stark contrast between the past and the future. The traditional IT paradigm relied on super cumbersome hardware provisioning. Rigid, fixed ratios of compute, storage, and networking. It literally just can't adapt to modern demands. The new AI paradigm? Well, that requires a hyperscale-class unified software stack. It absolutely demands relentless optimization of power usage effectiveness, or PUE, and strict thermal management. Why? Because these new GPU-powered supercomputers run incredibly hot and just devour vast amounts of energy.
To really put the scale of this shift into perspective, just think about the number 4,000. Current trends are pointing to a massive, non-linear ramp-up toward 4,000 new AI data centers by the year 2030. That is wild. Because of this astronomical growth, time to deploy is going to become the single most critical business KPI for any operator out there. Literally, any delay in getting a data center online crushes revenue. And that urgency, that's exactly why the SuperCloud Developer Console was built in the first place, to completely eliminate those delays.
Moving on to Section 2. Storage and network foundations, the foundations of NeoCloud.
Okay, so a crucial piece here is how you physically allocate your storage drives. Listen carefully because this is a hard-learned industry secret. If you're using standard SAS or SATA drives to store your Kubernetes Core KCOW virtual machine images, you are in for, as Kevin puts it, bad news bears. They just aren't fast enough. Kubernetes is extremely temperamental when it comes to speed bottlenecks, so NVMe drives are absolutely mandatory for your fast storage pool. You can totally save those slower SAS or SATA drives for your OS repositories or cold storage ISOs. On top of that, your backend storage needs to utilize NFS servers, carefully mapped via UUID using the blidkid command in your fstab file. That just ensures reliable booting. And as for the hypervisor itself, we're talking CentOS 10 utilizing a tool called Cockpit, which completely deprecates and replaces those legacy, headache-inducing RDP and virtual machine managers. Game changer for sure.
All right, with storage locked in, let's talk network plumbing. We start right at the top with leaf and spine top-racked Layer 2 and Layer 3 switches. Through these, we establish our 802.1q trunking to securely tag our VLANs. Next up, we use that cockpit tool I just mentioned to create our Linux bridges with a single click. That means no more fighting with messy, error-prone legacy network manager scripts, thank goodness. Finally, we route the whole setup through an OpenSense and WireGuard server, deployed on a super robust Supermicro Big Twin system. This securely nats and air-gaps our tenant traffic, which is absolutely perfect for a multi-tenant cloud environment.
Let's jump to Section 3, building the control plane, orchestrating cloud ops. Now, to really grasp the control plane, you first got to understand the concept of a shard. Think of a shard as a geographical or isolated boundary within your overarching GPU tenant cloud. Imagine you're dividing your operations up into north, south, east, and west shards. Each shard can run its own completely secure, isolated environment, like an Ubuntu 22.04 LTS setup, for example, servicing very specific tenant clusters without any of that data bleeding over into the others. It's like a perfectly organized filing system. So to actually deploy this control plane across your shards, your tool of choice is going to be KubeSpray, specifically version 2.27.0, just to guarantee absolute compatibility here. When you're building this out, there's a golden rule. Always, and I mean always, use an odd number of master nodes. We're talking 3, 5, or 7. This is totally non-negotiable for N+1 redundancy. You have to prevent a catastrophic single point of failure. Once your cluster is fully deployed, you securely import it right into the developer console using your certificate authority, client server, and client key certificates.
Which brings us to Section 4, Instantiating Virtual Machines, starting production.
Now, what's really interesting about this setup is how it simplifies literally everything for the end user. As an admin, you predefine these hardware resource combinations, which are known as flavors. So you might set up a standard VM with 4 cores, or maybe a massive multi-GPU container with 16 cores and 3 GPUs. By doing all this heavy lifting up front, your DevOps teams don't have to guess. They can effortlessly and, more importantly, consistently deploy the exact environments they need for their specific workloads without breaking a sweat.
And because we've laid this foundation out so perfectly, spinning up these operating systems becomes a totally seamless one-click operation. Whether your developers are asking for Windows 11, Ubuntu 22.04, CentOS, or Rocky Linux, it deploys instantly. Actually, it gets better. Through a built-in VNC console, you are dropped immediately right into the operating system. And thanks to those Linux bridges we set up just a minute ago, these VMs have instant outbound network access. You can run commands like apt-get update or simply browse the web right out of the box. So cool, right?
All right, Section 5, Deploying AI Containers, GPU as a Service.
I absolutely love this quote from Kevin because it perfectly highlights the ultimate payoff of all that incredibly complex underlying architecture we just went through. For the developer, all of that complexity is entirely abstracted away. With literally a one-click operation, they can instantiate a container and boom, a fully functional Jupyter notebook pops up on their screen, instantly hooked into the cluster's GPU resources. It really, truly is that simple for the end user.
And let me tell you, those backend resources are staggering. Take the Mars cluster configured in the console, for example. This beast utilizes Intel-based servers equipped with 8 massive NVIDIA H100 80GB GPUs. It is completely primed to instantly host PyTorch and TensorFlow instances. But what's also incredibly exciting here is that the SuperCloud architecture is agnostic. They're actively building support for a framework called Hami, which is going to allow seamless GPU slicing across completely different architectures. That means you won't be boxed in just using NVIDIA. You'll be able to fire up AMD's MI300 series accelerators just as seamlessly. Wrapping up with Section 6, the NeoCloud Future, Real-World AI Inference. So, during a live demo over in Madrid, the team proved exactly how well this works. Using the San Jose cluster right inside the developer console, they instantiated a local AI chat model, specifically the Gamma model, with just a few clicks. They fed it real-time inference queries, asking things like who is Elon Musk and where is Tucson. And because this model was running locally on their own dedicated GPU hardware, right within their secure shard, the generation was instantaneous. It was incredibly detailed and, best of all, fully air-gapped from the public internet. This right here is the true power of on-premise AI inference.
Which leaves us with this final, absolutely critical thought. We are looking down the barrel of 4,000 new hyperscale AI data centers being built by 2030. The unified software stack, the NVMe storage, the precise VLAN plumbing, and that magical one-click developer console, this stuff isn't just a luxury anymore. It's a sheer necessity. Mastering this blueprint today is literally the only way your infrastructure is going to survive the hyperscale demands of tomorrow. So the real question is your infrastructure ready to deploy at the speed of AI? Thanks so much for joining me for this explainer, and keep learning.